Alright, in this video we are going to work on the horizontal renderer. If you remember in the last video we created the horizontal renderer so that we could test out our new renderer system, but at the moment all we've done is copied some temporary drawing code into it. What we're going to do in this video is begin placing all of the information, things like our texture fields, our staff metrics, and so forth. We're going to drop down a series of fields and put together in a set of initialization instructions inside of our constructor.
Right, well there's a lot more that our horizontal renderer needs to do other than just make a few dots and tick them across the screen.
That's right, in the end it's going to need to do things like draw visual track indicators so we can actually see where our tracks are placed. It's going to be responsible for drawing the main hit line. It's also going to be responsible for doing some more advanced things like drawing visual beat indicators and visual measure indicators, as well as drawing the names of each individual track. So there's quite a few things we'll need to address. And to begin with, we'll need some fields so that we can keep all of this information together as we draw it. So starting here in the RendererHorizontal class, let's put together a set of fields. All of these fields will be private to the renderer itself. So we'll make an integer field called screen center. And this is simply a way of storing the screen center so that we don't have to constantly recalculate or divide our overall fixed width by 2. Alright, next up we've got a field called staff height. And in the last video we had mentioned that the concept of the renderer as it's drawing a song is to put together a kind of visual musical staff. And we're going to store what the height of that staff would be to make it easier to do things like position the overall staff on screen.
Right.
Moving on from here, we have another field called span height.
Now, what is a span?
Span height is going to be closely related to staff height. The idea with span height is that the staff visually is going to have a top and a bottom indicated by some solid lines. And the span is going to be all of the space inside those top and bottom lines.
Okay.
The reason for calculating a span height is different than a staff height is so that things like the start line and the beat lines can be drawn inside the edges of the staff rather than overriding them.
I gotcha.
It's a small tweak, but it does enhance the solidity of the final result.
It's an anti-overlapping feature.
Exactly. It makes it so that any vertical lines you draw aren't slicing up the border lines of your staff.
Because you care about that, that tells me off the bat that we're going to be dealing with lines that are semi-transparent and you don't want to see the alphas stacking up on top of each other.
Exactly, and just to keep everything accurate. Alright, moving on from here, we've got one more, you could say measurement field. We're going to make a field for track height. And this is going to be the height of an individual track. So we'll actually be calculating the staff height based on this value. Since if we have a track height defined, and we also know how many tracks we have because we've stored that in our configuration class, we'll then be able to figure out the staff height. It is still useful to maintain the individual track height as we're doing other calculations while drawing. Alright, moving on from here, we're going to put together some fields to hold information about the note texture. Now we do already have the note texture defined in the style class, but in order to keep the code as compact and concise as possible here in the renderer, we're going to keep a local reference as a field. And we're also going to need to store a few other pieces of information. So we'll drop down a texture 2D field called note texture. We're going to drop down another field, an integer, to store the note width. And once again, this is simply going to be the actual width property of the texture itself. It's stored separately just to make it easier in the calculations we'll need to put together, since we'll be dealing with enough complexity when we do screen transformations and positioning. Just to make it one step easier, we'll drop the value directly into an easily accessible field.
And that's really the point of a lot of these, to make sure we don't have to keep calculating this stuff over and over again.
Exactly. It makes things more concise and more verbose as we write all of the code. Alright, one more field that we'll need for our texture information, and that is going to be note origin. And note origin is going to be used for both efficiency and readability sake, since the origin is going to have to be calculated based on the texture's dimensions. We'll get half the width and height to give ourselves a point centered on the texture. But in order to prevent from having to recalculate that every draw call, we'll store it into a field. Now we'll have one more field here inside of the RendererHorizontal class, and that is going to be an array of vector2 positions. So a vector2 array, and we will call this array title positions.
And what's this going to hold exactly?
Well, if you remember back in the config class, if we jump here to game briefly and bring up our config class, we have this list of strings that consists of all of our track names. This is great for knowing what the names are, but we'll need to know where to draw them on screen. Now, as we're inside of our draw method, we'll be able to find that using things like our get staff position and looking at our track heights.
Sure.
So we'll know where our tracks go, and therefore we can find, well, we'll just place the track title into the track it belongs to. Where an interesting problem comes in is we want to draw our tracks first, then draw our notes, and then draw the titles on top of the notes.
Right, we don't want the notes to slide over those titles.
Exactly. But now we're in an interesting scenario where we're drawing the tracks first, but we need to retain that position and remember where we drew the tracks so that later in time we can draw the titles at the same position. So we're going to make a vector2 array to store those positions. That way when we draw the tracks, we'll record their positions into this array, and then later in time, after the notes get drawn, we'll still have the positions in order to draw the titles. Alright, now that we've got our fields put together, we need to get all of these fields initialized. And we're going to do something else in this video too. While we're getting things ready and set up so we can begin writing our draw code, let's also drop in all of the renderer settings into our style.xml settings file. If you remember back here in content, inside of the style folder, we have this style settings file, and we have a handful of settings here that all describe things used in the renderer. Things like the track lines themselves, the titles drawn on the tracks, the beat and measure marks, as well as a starting mark and a hit line. We're going to go ahead and set all of these just to make sure that we have the color settings in place. That way we don't have to worry about them one by one as we draw them throughout the renderer class. So starting up here on track, let's start plugging in some color information to our nodes. Beginning with track, we're going to set a red value of 134, 134, and 141. So a slightly more bluish gray color. Then for our track title, we're going to have a setting of 184, 184, and 191. Then moving down to beat mark, we have values of 134, 134, 141. Then our beat mark measure, which is going to be brighter than the individual beat marks. This is going to be 184, 184, and 191. Moving down from here, we have the start mark. Now, start mark is going to be a red line drawn at the very beginning of the song, basically to indicate that the song start. So we're going to draw this with a red of 255, a green of 96, and a blue of 96. Then one last node we're going to fill in here, and that is the hit line, and it is going to get a color of
174,
174 in blue,
174, 81, I'm sorry, 181,
and 181.
and 64.
And the interesting thing here is we're going to go and add a fourth component so that we can describe the alpha channel of this color and drop in a value of 64, indicating that the hit line is going to be drawn transparently. So we'll make sure that this style XML file gets saved out, and now we can turn our attention back to the RendererHorizontal class. Alright, now that we've got all of our visual style settings out of the way, let's put together a constructor for the horizontal renderer class that takes care of initializing all of the fields. So we'll make a public constructor here. So we'll have public RendererHorizontal, and we will put together all of our fields beginning with the note initialization. And since there's a handful of things to put together here, I'll drop down a comment over each section. So we'll begin with note initialization, or note init. And it's here where we will copy the note texture reference to our local note texture. So we'll take the note texture field in this class and set that to be equal to style.noteTexture. We'll take note width and set that to be equal to note texture dot width, and we will calculate our note origin. So note origin will be equal to a new vector2, and that vector2 is going to take in note width divided by 2 for the x component. We're also going to need access to height as well, so I'm just going to look all the way back to the note texture itself. So note texture dot width divided by 2 will give us our origin in x, and note texture dot height divided by 2 will give us our origin in y. And that vector2, of course, will get stored into note origin. And now we can look at a set of staff metrics. So you could say that these are all the fields that are going to measure or otherwise position the elements of our staff. Beginning with the screen center. So we'll say that screen center is going to be equal to the overall fixed drawing width divided by 2. And for that, we'll look into global state. We will access fixed drawing width and divide that by 2. Alright, next up, we're going to set our track height based on our note graphics height. So we'll take track height, we'll set that to be equal to note texture dot height. Because if you remember, the note texture itself has the padding already saved into the graphic file itself. So that means we simply take the height of the texture itself and we'll use that for track height. Alright, moving on from here, let's calculate our staff height. We'll take staff height and we'll set that equal to the height of an individual track multiplied by the total number of tracks. Now once again, the number of tracks is going to be defined here by our config file with track names, since track names and colors were originally loaded out of the XML file describing all of our tracks. So that means our number of tracks is going to be config.tracknames.count. Now, one more field to put together for our staff metrics, and that is the span height. So this is going to be the height that's going to be contained inside of our staff, inside the top and bottom line. So we'll put down a field called span height, and we'll set that to be equal to staff height minus 1. Now you may be wondering why we're only taking 1 pixel away from staff height instead of 2, since we've described that the staff is going to have a height, and then we want a height to fit inside the top and bottom line.
Yeah, you'd think you'd need to take away 1 pixel on top and 1 pixel on bottom.
But in this case, the way that we're going to draw the bottom line of the staff is actually going to be 1 pixel beyond staff height, just because of the way that we're going to be drawing the lines.
That makes sense.
Track by track, we're going to be drawing the lines on top of each track. To get our bottom line, we're simply going to draw an additional unused track. But because of the calculation, that track is going to fall 1 pixel out of our staff height, and therefore we only have to take 1 pixel away from staff height to give a span height that will stay visually within the staff itself.
I'm with you. So what does that leave?
That leaves the initialization of our title positions array. So let me drop down a comment here for titles. And we will create the vector2 array that we're going to store title positions in. So that means title positions array is going to be equal to a new vector2 array, and then we need to declare how many elements we're going to have in the array.
Which would just be the number of track names.
So once again, config.tracknames.count. So we could simply steal this value, drop it in place as the number of elements for our array, and that will take care of initializing a vector2 array with enough elements to store all of our track title positions.
Groovy.
Now with that, let's build, make sure this class gets saved out, and we have all of our fields set up. We have all of our fields initialized. We've also taken care of getting all of our staff and renderer color settings placed into our style XML file. So with that, we're going to go ahead and stop this video and pick up with some drawing code in the next video.
Cool.